Hello. In this video, we're going to investigate the following limit. We have the limit, as x approaches infinity, of the following rational function. Now, in this case, because we have a rational function, our best method is going to be to factor out all of the powers of x from each term so we can investigate what's going on in the limit. Now we're going to use a technique that I call force factoring. And to remind you what that means, if we have the following expression, 3x plus 4, although there's technically nothing in common between both the 3x and the 4, we can still force factor a 3x, giving us 1 plus 4 over 3x. I call this force factoring because although we are factoring, it does feel a little bit forced. But this is incredibly useful for us because now as x approaches infinity, 1 will just approach 1, and 4 over 3x, x will get very large, and so when we have 4 over a very large number, this term will all go to 0. We'll still, of course, have the infinity out here with the 3x, but it will make everything in our bracket here just a 1 plus 0. So what we're going to do is we're going to force factor each one of the terms and see what we get. So we still have the limit as x approaches infinity of, from this first one, we want to factor out the highest power of x. So we're going to have the 2x to the power 3. So we'll factor out a 2x to the 3. And because it's all squared, when we factor it out, it will come out as squared. Now it's going to be left with 1 minus x over 2x to the 3 plus 1 over 2x to the 3, still squared, times, and this here is just off to the side, 3x, 1 plus 4 over 3x. Now in the denominator, we will factor out a x to the 4, giving us a 1 minus 3x to the 3 over x to the 4, minus 2 over x to the 4, and from this term we can factor out a 2x to the 2, giving us 1 plus 1 over 2x to the 2. Now, if we look here, we need to simplify because there are some terms that we can cancel. Here we have an x over a 2x to the 3, so I'm going to want to cross off the x and reduce the power here to a 2. Here I've got a 3x to the 3, so we'll cross that off, giving me just x to the power 1. So that looks like all of the terms I can simplify there. But we're going to want to square this and bring the 3x over, bring the x to the 4 and the 2x squared over, and combine all those x terms. So now we will have the limit as x approaches infinity of 2 squared will give me 4 times my 3 will give me 12. And looking at our powers of x, we'll have x to the 3 squared, which will give x to the 6, times an x. So we will have x to the 7. And then, of course, rewriting all of the terms we had from our brackets. Times 1 plus 4 over 3x. And this is all over. Here we have an x to the 2 and an x to the 4 with the coefficient of 2, giving us 2 x to the 6. and still rewriting our brackets, 1 minus 3 over x minus 2 over x to the 4 times 1 plus 1 over 2x squared. Okay, again, looking at what we have, there's an x to the 6 here and an x to the 7, so we can cancel, leaving us with just an x in the numerator. So now that we've collected all of the terms we can go ahead and evaluate this limit. And so what we're going to see is that as we limit, this will stay as a 1, but this term here will limit to 0, as will this term, and this term, this term, this term, and this term. So in our limit, we will have 12, and x is approaching infinity, so it'll be 12 times infinity. And this is just times 1 over 2. This is 1, and this is 1, all over 2, which will equal infinity. Again, we need to remember our rules when working with infinity. If we have a number times infinity, it's still infinity. And if we're dividing infinity by a number, it's still infinity. Thanks for watching.